So for this problem, we've got an airplane flying over a radar tower. You can pause it, read it, and see if you can draw the same picture that I have here. Okay, so why did I choose 5 for this length? The airplane stays at a height or an altitude of 5 miles above the ground. Um, the distance x is changing there, that the airplane's path, right? So as it flies past the antenna, now the plane's going to, be moving in this direction over here. So x is changing. So now it passed over here. I'm going to kind of just erase that part. Okay, and there's your right angle. That's where it passed, but now it's past it. And we're going to study the moment when it's exactly 10 miles past going over the antenna, directly over the antenna. So then I've got the distance from the radar station to the plane. That's also changing, so I'll call that distance y. They want to know what is the speed of the plane. So that means what is the rate at which this length is changing. That's the same direction the plane's going, right? So dx dt is what we're looking for. We must need to know dy dt. And they tell us that the rate at which the distance between the antenna and the plane, so from the antenna directly to the plane, right, that rate is changing at 240 miles per hour. So that's a positive rate because y is going to be growing. We also expect the speed of our plane to be positive because x is growing. We do get a little bit into velocity here with directions. Is the plane going in a positive or negative direction? But we'll talk about that at a later time. So dy dt is 240 miles per hour. So the formula we're going to use here is a Pythagorean theorem because we're talking about the lengths of the sides of a right triangle. So then if I go take the derivative, I get 2x times dx dt plus 0 equals 2y times dy dt. So I need to know what? Everything except the rate I'm looking for, dx dt. So what's x? Well, x is 10 now. Now I can freeze the picture and plug in my x. It says when the plane is 10 miles past, so x is 10. dx dt is what we're trying to solve for, the speed of the plane. dy dt is 240. Y, we need to find, we can use our equation. We're going to go on the side and find that. Our original Pythagorean theorem, right? Well, we know when x is 10, so I've got 10 squared plus 5 squared equals y squared. So I do Pythagorean theorem out, I solve for that, and I get the square root of 125 for y. So we could simplify that to 5 root 5. Yeah. So we've got, I'll simplify here as I go as well. I've got 20 times dx dt equals 2 times 5 root 5 times 240. So if I simplify and solve for dx dt, again, you can pause and get there. See if you can get there. You get 120 over root 5 miles per hour.